Welcome guys, welcome back to my channel Study Be Like. In this video we will learn about the chapter Electricity and Magnetism. So let's begin. Before studying the chapter, we should learn about the prefaces such as introduction, what is electricity, law of electric charges, static electricity, electric currents, conductors and insulators, electric circuits, what is magnetism, magnetic fields and electromagnets. Now we will establish the relationship between electricity and magnetism. Electricity can produce magnetism, and so magnetism can create electricity. When charges from one piece of matter interact with those from another piece of matter, they produce both electric and magnetic forces. Now what is electricity? Electricity is the interaction of electric charges. Electric charges are a fundamental property of protons and electrons which make up every atom. Positive and negative charges are the two types of electric charges. Protons carry a positive charge whereas electrons carry a negative charge. Now we will learn about the law of electric charges. The electric force is the attraction or repulsion between the charged objects. And what is Coulomb's law? Coulomb's law states that the size of the charges and the distance between them are both key factors in determining the strength of the electric force between charged objects. Now we would study about static electricity, the build-up of electric charges on an object. When you rub a balloon against your hair, electrons from the atom that make up your hair transfer to the balloon, which makes your hair positively charged due to the electron loss. The balloon becomes negatively charged due to the electron gain. When you hold the balloon several centimeters from your head, your hair stands up due to the attraction between two opposite charges. Now we would study some points about current electricity. Current electricity is a continuous flow of electric charge. Current is defined as the quantity of charge that flows past a given point per unit time. The standard unit of measurement for current is ampere. Direct current, a type of electric current where the charges flows in one direction only. Batteries are example of direct DC source. Whereas alternating current, a type of electric current that flows in one direction then the reverse direction repeatedly. The electric current supplied by the power companies to homes is an example of AC. Now we will study about conductors and insulators. Conductors are materials that allow an electric current to flow through them easily, whereas insulators are materials that resist the flow of electric current. Examples of insulators: rubber, glass, plastic, air, wood and paper, whereas examples of conductors are metals such as copper, aluminum, silver and gold. Water, when it contains dissolved salts or any other charged particle. Graphite, found in pencils, and human body can conduct small amounts of electric current. That's why humans get electric shock. Now we would study the parts of a circuit. Energy source. An electric field created by a battery's positively and negatively charged terminals attract and repels charges, providing the push to keep them moving through a closed circuit. Load, a component in a circuit that consumes electrical energy to perform a function such as generating light or motion and resists the flow of electric current, causing a voltage drop. Wires, a low resistance conductor that carries current in a circuit connecting components. Materials and thickness selected based on distance, current and voltage for efficient and safe operation. Switch, a switch contains a circuit by connecting and disconnecting two metal pieces. Now we would study about the types of circuit. Current flows through a closed circuit, a loop with no brakes, but an open circuit has a brake and stops the current flow. There are several options for connecting multiple loads in a circuit. There are two of the most common approaches. Series circuit, this involves connecting the loads in a line or a series, allowing the current to flow from one load to the next in a single path. Parallel circuit, here the loads divides the current amount of the different devices, creating a parallel connection. Now we would study about Ohm's law. Ohm's law describes the relationship between electrical energy and voltage in a conductor, stating the amount of electric current flowing through the conductor is directly proportional to the voltage that is causing the current to flow. I is the current measured in amperes, V is the voltage and R is the resistance of the conductor measured in ohms. Divide V by R to find the current and divide V by I to find resistance. This is all about Ohm's law. Now we would learn that what is magnetism, a force that can attract or repel certain materials such as iron and is caused by the movement of electric charges within certain objects like magnets or electric currents. Magnets attract iron and have two poles, a negative and a positive pole, where the magnetic pole is the strongest. All magnets share these properties. Like charge repel each other and unlike charges attract each other. Now we would study the region around a magnet that is affected by magnetic forces. What do you think it might look like? A magnet is always surrounded by magnetic field lines which are always unidirectional, because if we draw a tangent, it will give only one direction in which it is moving. Now we are going to learn an interesting fact that Earth's magnetic field is what makes compasses work. The needle of a compass is a tiny magnet that aligns the Earth's magnetic field pointing north-south. This is possible. The Earth itself acts as a giant magnet thanks to the magnetic core, which generates a magnetic field that extends far into space. This field is what protects us from the solar wind and other harmful particles that constantly bombard our planet. Without it, life on Earth as we know it would not be possible. Now we would study electromagnetism. Physicist Hans Christian Oersted was the first to discover that electric current produces a magnetic field around a wire. To produce a strong magnetic field, wrap coils of wire around a iron rod. Current passing through the coils magnetizes the rod, producing a powerful magnet called an electromagnet. The more loops in the coil, the stronger the magnetic field. Electromagnets are used in electrical motors, loudspeakers, television sets, doorbells, and other devices. Faraday's electromagnetic induction, the process of creating an electrical current by moving a conductor through a magnetic field or varying the magnetic field around it. The majority of the electricity supplied to homes is generated using electromagnetic induction. With this, we are marking an end to our chapter Electricity and Magnetism. Hope you guys enjoyed our video. If you truly like this video, please do like, share and subscribe our channel Study Like. And thanks for watching till the end. Please share it with your friends.